In this video, we will be configuring EIGRP to route traffic from one local area network to another local area network over a wide area network. EIGRP stands for Enhanced Interior Gateway Routing Protocol, and it is used to propagate advertised routes from one router to another router. Here, we will be configuring EIGRP on routers 1 and 3 and on routers 5 and 2. EIGRP on router 1 will be advertising the 192.168.0.0 network, as well as advertising the 172.16.10.0 network, otherwise building an adjacency from router 1 to router 3. Router 2 will be advertising the 192.168.1.0 network and building an adjacency with router 5 over the 172.16.20 network. Router 3 and router 5 will not, however, be advertising the 10.1.10 network or the 10.1.20 network with router 4. Therefore, router 1 will not be able to send traffic over the WAN with EIGRP alone, since router 3 and router 5 and router 4 will not be using EIGRP to pass traffic back and forth. We will have to build a tunnel from router 3 to router 5 and use EIGRP over the tunnel in order to send traffic from one local area network to the other local area network. We'll start by turning on all of our ports and configuring IP addresses. Router 1 is using Gigaport Ethernet 0, 0, and 0, 1. No shut. Router 3 is using Gigabit Ethernet 0, 0 and serial 0, 0, 0. Router 4 using serial 0, 0, 0 and serial 0, 0, 1. Router 5 using serial 0, 0, 0 gig 0, 0 router 2 using gig 0, 0 and gig 0, 1. Now all of our ports have been turned on. We will configure IP addresses. Router 1's internal interface is gig 00. Its IP address will be 192.168.0.1, and it is a /24. It is 255.0. The laptop will be 192.168.0.2. /24 with a gateway of 0.1. The laptop should be able to ping the router. We will do the same thing on router 2 and laptop 2. IP address 192.168.1.1/24. And the laptop will be 1.2 /24. Gateway is 1.1. And it should be able to ping the router. Now we will configure the IP addresses between router 1 and router 3, as well as router 5 and router 2. That is gig 01 on router 1 and gig 00 on router 3. IP address 172.16.10.1/30. On router 3, interface gig 00, IP address 172.16.10.2, 255.255.255.252. Router 1 should be able to ping router 3. Ping 172.16.10.2. Laptop 1, however, will not be able to ping router 3 until we configure EIGRP. Before we do that, we will configure router 5 and router 2. Gig 01 on router 2 and gig 00 on router 5. (16.20.1/30). IP address is 172.16.20.2 on router 5, 255.252/30. Router 2 should be able to ping router 5. Ping 172.16.20.2. Now we will configure EIGRP for our local area network, connecting laptop 1 to router 1 and to router 3, And we will also configure EIGRP to connect our other local area network for laptop 2 to router 2 to router 5. The autonomous system number we will use will be 100, and we will use it for both local area networks. That way, when we are ready to connect both local area networks, they will be using the same autonomous system number. We'll start with router 1. Configure terminal. Router EIGRP 100. Network 192.168.0.0 255.255.255.0. This will advertise router 1's backside network. Network 172.16.10.0 255.255.255.252. This will build the adjacency to router 3. Gig 00 is the interface going to the backside for router 1. We will make gig 00 a passive interface in EIGRP. This means that router 1 will not send any EIGRP packets out of gig 00 to update any routers out of that interface. That interface is for router 1's local area network, and so it will not need to send any hello packets out of gig 00. It will, however, need to send hello packets out of gig 01, so gig 01 will not be passive. We will now configure router 3 with EIGRP. Router EIGRP 100. Network 172.16.10.0 252. Router 3 has a new adjacency with router 1, that is 172.16.10.1. Laptop 1 now should be able to ping router 3. That is 172.16.10.2. It will not be able to ping, however, router 4. 10.1.10.2. Destination host unreachable. We still have to configure the IP addresses, but even when we do, it will not be able to ping router 4. Serial 000. .1.10.1/30. IP address 10.1.10.2 for serial 000 on router 4/30. Router 3 should be able to ping router 4. Router 1, however, will not be able to ping router 4. and laptop 1 still will not be able to ping router 4. We'll finish configuring the IP addresses connecting router 4 and router 5, the 10.1.20 network. Interface serial 0101, IP address 10.1.20.1. And on router 5, .000, IP address 10.1.20.2 /30. Router 5 should be able to ping router 4 20.1. It will not, however, ping router 3 because there are no routing protocols, and router 5 does not know that route. 10.1, and it will time out. We will continue to build EIGRP for our other local area network. For router 5, router EIGRP 100, network 172.16.20.0/30. On router 2, router EIGRP 100, network 172.16.20.0/252. And now router 2 has an adjacency with router 5. Router 2 will advertise its backside 192.168.1.0/24, and router 2 will propagate that advertised route to router 5 using EIGRP. We will make the backside interface gig00 passive so that EIGRP packets are not using any bandwidth on router 2's backside network. Laptop 2 should now be able to ping router 5. .2. It will not, however, ping the 10.1.20 network. Destination host unreachable. So now EIGRP 100 has been enabled for the local area network 192.168.0.0 and 172.16.10.0. It has also been enabled on the local area network for 192.168.1.0 and 172.16.20.0. Router 3 needs to be able to ping router 5 to complete our wide area network. We will use static routes. On router 3, configure terminal, IP route to 10.1.20.0/30. Next hop will be 10.1.10.2. Router 3 should be able to reach router 5. However, router 5 will not be able to send it back to router 3 because router 5 does not know about router 3. So router 5 will also need a static route, IP route 10.1.10.0/30, next hop 10.1.20.1. Router 5 should be able to send a ping to router 3. We will verify to make sure we configured it correctly. Ping 10.1.10.1, and router 5 can now ping router 3. Although EIGRP has been enabled for routers 1 and 3, as well as routers 5 and 2, router 1 will not be able to use EIGRP to ping over the wide area network to router 2, since router 3, 4, and 5 are not using EIGRP to pass traffic. Router 1, try pinging 172.16.20.1, and it will time out. Since we are not using EIGRP on our wide area network, router 3 and router 5 will need to build a tunnel so that we can pass traffic using EIGRP from one local area network to the other. We will use tunnel 100. And it will be connecting our two local area networks, and it will be using EIGRP 100. Router 3, interface tunnel 100. IP 10.1.100.0/30. IP address 10.1.100.1/30. Tunnel mode GRE IP. Tunnel source will be the physical interface serial 000. Tunnel destination will be router 5's serial 000. We have to specify an IP address, otherwise router 3 will not be able to detect what the IP of that interface is. 10.1.20.2. Line protocol on interface tunnel 100 changed state to up. For router 5, configure terminal, interface tunnel 100, IP address 10.1.100.2, 0.0.0/30. Tunnel mode GRE IP. Tunnel source 0000. Tunnel destination 10.1.10.1. Line protocol on interface tunnel 100 has changed state to up. Now we need to build an EIGRP adjacency between router 3 and router 5 using the 10.1.100 network. Router EIGRP 100 network 10.1.100.0/30. And the same on router 5. Network 10.1.100.0/30. We now have an IP EIGRP adjacency through our tunnel 100. Now both of our local area networks are using EIGRP, and they are both connected through tunnel 100. Router 3 should be able to ping router 2. Router 1 should be able to ping router 2. Laptop 1 should be able to ping laptop 2. We'll go to laptop 1 and we will ping laptop 2, which is 192.168.1.2, and we are receiving replies. To see this in simulation, we will send another packet. When the packet reaches router 5 on the return, it will change its IP header to the tunnel IP network 10.1.100. And then it will change back to the 172.16.10 and then to the 192.168.0.0. And now we have connectivity from one local area network to the other local area network using EIGRP and a tunnel to connect the two over a wide area network where EIGRP is not enabled.